Hello everyone, I am Rudresh. I am from Bengaluru. I am pursuing my engineering in Cambridge Institute of Technology North Campus. I am here to explain about a washing machine simulator by using PIC16F877A project. This project is done during the internship at Emertxe. For this project, we required some of the simulation softwares and C programming, writing a code and embedded C for writing a code for the hardware devices. Introduction to the project. Washing machines are devices which are used for cleaning of clothes without a person rubbing, scrubbing or beating the clothes by oneself and getting dirty. Washing machines have an important place in the modern society. Without it, one can imagine how difficult and tiresome life would be. Washing machines are used to reduce human labor and save time. Nowadays, we can see various kinds of washing machines, especially the fully automatic ones, as they are front runners in a store. Customers want to have a fully automatic washing machines instead of semi-automatics. We build a simple washing machine spin timer using a microcontroller PIC16F877A. Microcontrollers and microprocessor used to control a various electronic devices such as cellular phones, laptops, monitoring system, controlling systems, etc. Microcontrollers and microprocessors are used to perform a repetitive operation the same way timer after a time. They are cheap to produce and all their components are in the same package. They very rarely fail in operation. Introduction to microcontroller. What is microcontroller? An integrated circuit which is capable of being a program to perform a specific task. The design normally has restrictions on its memory, size, I/O capabilities, and peripheral functions, etc. The difference between microprocessor and microcontroller. Microprocessor will have a separate components. Microcontrollers are a single on chip. Microprocessor is more flexible. Microcontroller is less flexible. Microprocessors are more design complexity. Microcontrollers have less design complexity. Why we choose a microcontroller which have a more application compared to microprocessor? The performance is high, the price is less, the availability is more, availability of tools is more there. For example, it can be a software or a hardware which have a special capabilities are there. Introduction to embedded system. What is embedded system? Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. For example, microwave oven, washing machine, television, CCTV camera, refrigerator, car, automatic, aeroplane, ECG, DDD drive, etc. Categories of embedded system. The first one, standalone embedded system. Standalone embedded system does not require a host system like a computer. It works by itself. It takes the input from the input ports, either analog or digital, and calculates, calculates and converts the data given the resulting data through the connected devices, which either controls the drives and displays the connected devices. Example, MP3 players, digital cameras, video game console, etc. Real-time embedded system. Real-time embedded system is defined as a system which gives a required output in a particular time. This type of embedded system follows the time deadline for the completion of a task. For example, airbag system, pacemaker, missile. Networked embedded systems are related to a network to access the resources. The connected network can be a LAN, WAN, or the Internet. The connection can be any wired or a wireless. Example, router, home security system. Mobile embedded system. Mobile embedded system is used in portable embedded devices like cell phones, mobile, digital cameras, MP3 players, example, and also Google Car. Hybrid embedded system, which contains above all the embedded system in one. For example, a robot. Components of embedded system. Sensors converts a physical quantities to an electrical signal, then can be read by an electronic instrument or an observer. The sensor convert a measured quantity to the memory. Then analog to digital converter. An analog to digital converter converting any analog signals sent by this sensor into a digital signal. Then FPGA ASIC. The output is measured by the process and is stored in the memory. Then digital to analog converter, which converts any digital data which is given from the process to analog data. Actuators. In this system, the actuator will be composed the output provided by the digital to analog converter to a expected output. Requirements of an embedded system. Reliability is more, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. Real-time access. Hard real-time system should meet its deadline life critical application. Firm real-time system similar to hard real-time system. Soft real-time system can have a tolerance in meeting its deadline. Software to be used in this internship are MPLab XID, Xe8 compiler, and PIC16Lab. PIC16F877A PIC Genius board from the microchip. In this internship, we use a microcontroller called PIC16F877A. Its size of 8-bit, then its contents of 5 ports, namely as port A contains a 6-bit, it's used for only analog. Port B, its size is 8-bit, it's a bidirectional port. Port C, its size is 8-bit, which can be used as a digital pins used for a serial communication. Port D, its size of 8-bit, all are the digital pins. Port E used for this is the board, Big Genius board, which contains LEDs, keypad, interrupts, timers, clock, SSD, and CLCD, and matrix keypad analog inputs. We discussed the LED. LED is the simplest device used in most on the embedded system application as a feedback. Works just like a diode. Low energy consumption, longer life, smaller in size, faster switching make it usable in wide application field like Example, home lighting, remote controls, surveillance, displays, and many more. LED is an external device connected to a microcontroller port. A port is interface between a controller and external peripherals. Based on the microcontroller architecture, you will have a n number of ports. From the schematic, we have come to know the LEDs are connected to a port B and port D. Port is peripheral and we need to know on how access the address. This inform will be available in the datasheets in port B and port D and data memory sections. From the section of port B, it's clear that there is one more register associated with it named as a TRISP. The TRISP register is very important for I/O configuration. The value put in this register would decide the pin direction as shown in below. When we put to the TRISP register 1, it's act as an input direction. When we put the 0, it's act as a pin output. Which one is correct, A or B? B is correct because the switch is connected to the VDD. The positive terminal of the LED is connected to VDD and negative terminal of the LED is connected to the ground. This is the circuit. Tactile switch. Consider the below design. What will be the input to the controller if the switch pressed? There is no connection, valid connection is there. Will this solve the problem which may arise in the design mentioned in the previous slide? We missed in previous slide VDD. We put the VDD to the switch. It's completed? No. The VDD is directly given to the controller. It's damage to the controller because we can use the resistor in between the controller and VDD. Now will this solve the problem which may arise in the design mentioned in the previous slide? What would you call the design? It's called as the pull-up circuit. What would you call this design? Is a pull-down circuit? Is there any potential problem? No. Tactile switch bouncing effect. When we press a switch, the two metal parts come into contact to short the supply, but they don't connect instantly. But the metal parts connect and disconnect several times. Before the actual stable connection is made, the same thing happens while releasing the button also. This bouncing effect can be eliminated by giving the delay. Then discuss the interrupts basic concepts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external devices request the MPU to stop the processing. The MPU acknowledges the request, attends to request, goes back to the processing where it's interrupt. Polling. Interrupts can be classified as a hardware and software. In hardware interrupts, non-maskable and maskable are there. In maskable, we can divide it into two types, external and internal. Interrupt handling. is the main program. The super loop is the main program. When the main program is executed, one of the interrupt will come to the main program, which is stored in the timer. After the interrupt is done, interrupt is solved, then coming back to the same address of the interrupt. Interrupt service routine, similar to the subroutine, attends to request of an interrupting source, cleans the interrupt flag first, should save a register contents that may be affected by the code in the ISR, must be terminated with the instruction RETFIE. When an interrupt occurs, the MU completes the instruction being executed, disables the global interrupt enable, places the address from the program counter on the stack, return from the interrupt. Then we discuss the CLCD. CLCD defines as a character liquid crystal display. In fixing glass, there are two types of display. One is 16 into 2 display and 16 into 4 display. It displays the ASCII character and some special character. It is most commonly used. Two types of communication modes, 4-bit mode and 8-bit mode. Timers introduction. Resolution, which means the register width. Take up count or a down count. Quantum system clock settings. Scaling, pre and post scaling. Modes, counters, PW and pulse generator, PW or PP measurement, etc. Timers. Timers is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring a time and generating the delays, etc. Timer or a counter is software designed to count the time intervals between the events. Resolution, which is also called as a register wait. Tick is referred as the changes from the one number to the another number. It may be up count or a down count. Quantum, which depends on the system clock settings, is measured of a time which is responsible for the tick. Scaling may be a pre-scalar or a post-scalar, maybe 1:1, 1:8, 1:16, 1, etc. Modes of timers are a counter, PWM pulse generator. Let's get into the project demo. In the first step, we have to turn on the washing machine by pressing a key fry. Powering on washing machine interface will be occur. After pressing a key 5, the machine will be started, and we have to select the washing programs like daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, daily, heavy. We select the delicates. For selecting the same key RB3 is press long time. After selecting a washing programs, then we have to select the water level. For selecting the same key 4. See this, these are the water levels: auto, low, medium, high, maximum. We can select a low water level by press the key 4. Then we have get the start stop interface to the user. If I want to start the washing machine, to go with the switch 5 to start. Otherwise, to stop the washing machine, press switch 6 to stop. This is the switch 5. We can start the washing machine by pressing switch 5. Program delegates, which shows the function, time, and start and stop. We can pause the washing machine by pressing a 6. We can check 6 is pressed. The system is paused. The timer is paused. Then the fan is paused. Once the washing machine will be started, at this time the door is open. This condition can be checked by this RB0. See this, washing machine will stop. CLCD also stop. After completing, program completed, remove a cloth. Thank you.